Okay guys, so let's look at writing and solving equations, and then on inequalities we only have to write inequalities, you do not have to solve them. So I know on this first problem it looks a little bit crazy because it has all of these fractions, but don't stress about that. So let's first start by writing the equation. So Kia's plant is 8 1/5 inches tall. I know that's the starting point, so that's going to be my constant. That's not a rate at all, so there will be no x associated with that. And is growing, so I know that's a plus because it's getting taller. It's 2/3 inch each week, so I know that's a rate, so I'm going to have an x associated with that. Then Lyric's plant starts out at 10 7/10 inches tall. So I know that's the constant, that's where it is starting. And then it grows, so I know that's going to be a plus, 1/6 inch each week. Now I know these fractions look a little bit crazy, but again, with your graphing calculator, to find your fractions, if you go to alpha, y equals, 1 gives you a regular fraction, and 2 gives you a mixed number with a regular, I don't know why I'm writing x over y, disregard that. It gives you, so like numerator over denominator, and 2 gives you your whole number with the numerator over denominator. So you are able to type in those fractions to do this work. So if we solve traditionally, remember we want to get all of our variables on one side combined together and all of our constants on the other side combined together. So I'm going to take away this 1/6x. I'm going to take away 1/6x. This comes down, so I have 8 1/5 plus 2/3 x minus 1/6x. So basically I'm just doing 2/3 minus 1/6. That gives me a half x is equal to 10 7/10. These zero out, so they create a zero pair. Then my goal is to get the variable by itself. So I'm going to take away this 8 1/5 x, take away 8 1/5 x. I'm taking it away because to make a zero pair, if I have 8 1/5, to get rid of it, I got to take it away. So those make a zero pair. These make a zero pair. So I'm left with 1/2 x is equal to, so if I do 10 7/10 minus 8 1/5, I get 5/2. And then to get x by itself, I'm doing 1/2 times x. So the inverse of multiplication would be division. So I'm going to divide by a half, divide by a half. And I know that seems a little crazy, but these would cancel out and make a 1, leaving me with x. And if you take in your calculator and do 5/2 divided by 1/2, you would get x is equal to 5. So it would take 5 weeks for both of the plants to be the same. Now, if we wanted to do this using the box method, so if I have 8 1/5 plus 2/3 x is equal to 10 7/10 plus 1/6 x, I would make my boxes. So I would drop my 2/3 x because I'm bringing this to the other side. It becomes the opposite. So 1/6 x. I would drop my 10 7/10, bringing this to the other side. So it'd be a negative 8 1/5. When I combine my like terms or combine my terms, so if I add these together, I get that 1/2 x. If I add these together, I get that 5/2. And then doing just that last step of getting x by itself, I'm going to divide by half, and I get x is equal to 5. Now, over here with Trina sells vases, so she sells them for $24.50 each. I know that's a rate. They cost, so her cost to do anything is $4.25 for each one. And then she has to pay a one-time fee of $162 for her craft fair. So I want to know, we do not have to solve this. I'm just going to write the inequality on when she will have a profit. So how many vases she has to sell for her to have a profit. So for her to have a profit, that means she has to sell more than she pays. So I know that this has to be greater. So your final inequality that you would write would just be this right here. And that's it. So let's look at our notes on here. So our coefficient is the number that is attached to our variable. It's the co-pilot. It's the thing that is in front of the variable. It's usually what your rate is. So for example, it was like that 2/3 inch each week, or the 1/6 inch each week. That is my coefficient. My variable is the unknown. For example, in that problem up there, it was how many weeks. And then my constant is where I start out at. So for example, how tall it was when it started. So it's where, you know, just like when we were doing slope and y-intercept, your constant is where it starts, and then I have my rate added on. So when we go to solve, so whenever you solve equations, you combine like terms. In this case up here, there were no like terms to combine, and I'll show you in this example down here what they meant by combine like terms. And then we collect the variables on one side of the equal sign, and we collect the constants on the other side of the equal sign. So once we do that, then we remove the coefficient doing inverse operations. Just like we did here, we moved our variables to this side, and then we moved our constants over here to this side, and then we used inverse operations. So if I was doing 1/2 x, I divided by 1/2 to both sides to get my x by itself. We basically did the same thing over here. I put all of my variables on one side, all my constants on one side, combined them, and then did my inverse operations. So on here, when it's talking about combining like terms, so if you see how you have a 13x and an x here, notice how they combined them and got 14x. For example, if you had 13 apples and then you had an extra apple, you would then have 14 apples. So that's what it means by combining like terms. And then what they did is they moved this 2x over here. So they added 2x to both sides to get rid of that. And then they added this 6 to both sides to get it over there. And that's how they got 16x is equal to 8. And once they divided, be careful, because a lot of you would probably want to say, oh, well, that's just 2. But if you divide by 16 and divide by 16, that ends up being a half. So make sure you are very careful. Inequality signs, I will let y'all read over inequality signs. Make sure that you use this whenever you are doing your scavenger hunt here in a little bit, because those inequality signs will help you. And then with intersecting lines, that is your systems of equations type stuff. That's just kind of like the introduction. You'll get more into it in high school. But the point of intersection on the graph of two linear equations represents the value of x and y that are solution for both equations. So this point right here would be the solution for this line, and it would be a solution for this line. So whenever you're looking at that, it's where those 2 points intersect. So I'm going to go over one of these with you just so that you can kind of see how to write whenever we have these models. So if you notice, I have 1, 2, 3, 4, 5 positive x's, so that's 5x. I have a -1, so -1. I have 5 negative x's, so that's a -5x, and then I have +1. So my goal is to get all of my variables to one side, all of my constants to the other. So I'm going to add 5x, add 5x. So I get 10x minus 1 is equal to 1. And then I'm going to add 1, not 2, add 1, because I now want to get my constants to the other side. Add 1. So I'm going to move this over here. So I get 10x is equal to 2. And then I'm dividing by 10, dividing by 10. So x is either 2 over 10 or 1/5, or you may see it as 0.2. In this case, it was 0.2. So you would go down to card 9, work out card 9, and you should, once you work through all the cards, you should end back up at card 1. You can always check your equation by substituting your answer back in. So what that means is I have my equation 5x minus 1 is equal to -5x plus 1. If I substitute what my value, I said that x was 0.2. So I basically have 5 times 0.2 minus 1, -5 times 0.2 plus 1. If you type just this side, oopsie, if you type just this side into your calculator, you get 0. And then if you type just this side into your calculator, you get 0. So if these two equal each other, that means that you did the correct thing. It won't always be 0. It could be any number. But as long as they equal each other, you know you did the right thing. This is still my solution to the problem, though. That is still my answer to the problem. So if you have any questions, let me know. Otherwise, go through and practice this. Have a good day.